Question 9. Two cyclists S and Y leave turn O at the same time. Cyclist S travels at the rate of 5 kilometers per hour, that is the speed, on a bearing of 049 degrees. Remember, it's from turn O. And cyclist Y travels at the rate of 9 kilometers per hour on a bearing of 319 degrees. A part of the question: illustrate the information on a diagram. B part: after traveling for 2 hours, calculate correct to the nearest whole number. D, figure 1, distance between cyclist S and Y. Roman figure 2, bearing of cyclist S from Y. C part of the question: find the average speed at which cyclist S will get to Y in 4 hours. So you have solution. A part of the question: the two cyclists S and Y both journeyed from turn O. The bearing of S from O is 049 degrees, and the bearing of Y from O is 319 degrees. Now 049 is in the first quadrant and 319 is in the fourth quadrant. So turn O has to be somewhere here, so that 49 degrees from turn O to turn S, you can see in the first quadrant to turn S, and 319 degrees from turn O to Y, you have it in the fourth quadrant. As you are doing that, you must also consider the rate at which they travel. That helps you to draw diagram to scale. S is 5 kilometer and Y is 9, so 5 is shorter. So the distance, or the distance now from turn O to S, which we are to obtain from the speed, is shorter than the one of turn O to turn Y. So this is the diagram. Now Y is here 41. Now from this place like this, the whole of this place is 319, and you know that the whole quadrant is 360 degrees. So if from the north to this point here is 319, the remaining place here becomes 41 degrees. That is 360 minus 319. So the whole of this angle now is 90 degrees. 41 plus 49. That means that triangle SOY is a right angle triangle. So we are asked to find the distance between S and Y. Now we have to get the distance between O and Y using the rate. That is the speed, and the distance between O and S using the speed as well. You know, distance is speed over time. The time given to you is after 2 hours. So you can get the distance between turn O and turn S, then turn O and turn Y. Then you can find the distance between turn S and turn Y. Okay, as I have said, the speed is given to you and the time is 2 hours. In order to get the distance between S and Y, the distance between OS, or from O to S and from O to Y, is needed, and that distance is simply speed times time. The time is 2 hours. So distance from O to S is 5 times 2, that is 10 kilometers. The distance from O to Y is 9 times 2, and that is 18 kilometers. Now figure 1 of B, distance between S and Y can be obtained using Pythagoras rule, since triangle SOY is a right-angled triangle. You know SY is the side facing the right angle. That means SY is the hypotenuse. So you have SY squared equal to OS squared plus OY squared. So you have this expression after replacing OS and OY with their values. So you have SY squared is equal to 100 plus 324, and that is 424. To get SY, you take the root of both sides. So SY is equal to square root of 424, and that is 20.59. 20.59. To the nearest whole number, we are considering 20. The next number is 5. You round it up to 1 and add it to 20. You have 21 kilometers as the distance between cyclist S and cyclist Y. Roman figure 2 of part B should find the bearing of cyclist S from Y. That bearing is 180 degrees minus theta minus 41 degrees. Theta is needed. So let us have the diagram for better understanding of this part. The bearing of cyclist S from Y. From Y you go to Y, and you start from the north to that line that join cyclist S and Y together. This is the bearing, the angle you must get. And to get that angle, you know that the whole of that side, half of the quadrant, is 180 degrees. So if you subtract theta and 41 from 180 degrees, you get the remaining angles. So you must calculate for theta. And we can use sine rule, because now we know OS. We know that. Now this angle is known as well, and we know side SY. If you have two sides and one angle, you can get the other angle using sine rule. So you have OS. You can see OS here over sine theta equal to, you have SY over sine. Now this angle is 90 degrees. 90 degrees. Okay, to get theta, the expression is already here. OS is 10 over sine theta equal to SY from Roman figure 1 of part B is 20.59 over sine 90. You make sine theta the subject, you cross multiply and divide by 20.59. You have it in this form. You know sine 90 is 1. 1 times 10 is 10 over 20.59. If you divide, you have 0.48567. To get theta, you check the inverse of sine of 0.4857, and that gives 29.056 degrees. Therefore, bearing of cycle S from y is equal to 180 degrees minus theta. Now theta is 29.056 degrees minus 41 degrees, and that gives 109.944 degrees. To the nearest degrees or whole number there, you have 110 degrees. C part of the question: find the average speed at which cyclic S will get to Y in 4 hours. So the time that S will get to Y is 4 hours, and the distance between S and Y is 20.59. Average speed is simply distance over time. So you have distance between S and Y and the time between S and Y, and that is 20.59 divided by 4, and you have 5.1475 kilometers per hour.